So chapter 19 is about electrochemistry, one of my favorite topics. And I think this quote is awesome. So Michael Faraday could be considered the father of electrochemistry, lived back in the 17 and 1800s. And Gladstone was the British Chancellor of the Exchequer, and he questioned Michael Faraday about whether this was, electricity was practical at all, and why mess around with this. And Michael Faraday says, "One day, sir, you may tax it." So think about electricity. Is it practical? Heck yes. So electricity is generated at power plants, distributed through the power grid. Average U.S. household consumes about 1,000 kilowatt hours per month. And with technology advances, the option of disconnecting from that grid is becoming more viable. So you could do that using solar panels in conjunction with batteries. Not necessarily as easy as it sounds, because you have to do some fiddling around to make sure that your batteries are charging and everything. But definitely doable. And small fuel cell power plants are under development. Currently they can be used to heat water or to heat your home. And that would also be off the grid. Kind of cool. So what is a fuel cell? Fuel cells are very efficient, and they produce less pollution than fossil fuel combustion does. But there are still obstacles that need to be overcome. So fuel cells are based on oxidation reduction reactions. The hydrogen-oxygen cell is the most common type. And there are cars that run on these cells now, but the problem is you need the fuel for them. And how do you generate the fuel? So this is the reaction that's occurring. Hydrogen and oxygen combining to form water. So this is great because what pollutant is there in this, right? There aren't any pollutants. So what happens is the hydrogen and the oxygen are forming covalent bonds, but the electron pairs are not shared equally. So we have a shift in electron density. This doesn't really look like a redox reaction, does it? But if we were to look at oxidation states, we would see that the oxygen has been reduced. So the oxygen has more electrons in water than it does as O2. It's been reduced. In a hydrogen-oxygen fuel cell, the hydrogen and oxygen are separated, and in order for them to react, we force the electrons to travel through a wire, creating electricity.